Find the number of integers c such that the equation absolute value of, well, I'm not going to read this out. There's a whole bunch of absolute values going on. We want to find the number of integers c such that this equation has 12 distinct real solutions. Interesting. Even trying to figure out where the open and close of each absolute value quantity here is a little bit confusing. But there's an absolute value around x. There's another one around those, and another one around those. We'll see. So this is equal to 21. Okay. So this is supposed to have 20 distinct real solutions. Sorry, 12 distinct real solutions. I guess we have to just start thinking about which things are positive, which are negative, assuming, like, if we imagine that everything within an absolute value sign is positive, then it's simply a quadratic expression for x. In fact, it's an even expression, right? Whether x is positive or negative, it doesn't change anything here. So this is the absolute value around x. Essentially, so, okay. I'm going to rewrite this as 20x minus x squared, absolute value, minus c in absolute value is equal to 21. This having 12 distinct solutions, real solutions, is equivalent to this having 6 distinct positive real solutions. Right? If I have a positive real solution to this, replace x with negative x, and that gives us a different solution to that. 0, x equals 0, when would x equal 0 be a solution? We would need c to be equal to plus or minus 21. But if 0 is a solution, there will not be, well, maybe there will be other solutions, but they will still come in pairs. Okay, so we're only looking for positive solutions of this. And I guess the idea here now is to break it down into the case where this thing is positive or negative, then further break it down into the case where that thing, the whole thing, is positive or negative. And because it's a quadratic thing, there could be, for each combination of things being positive or negative, there could be up to 2 solutions. So that gives 8 in total. But we want 2 of them to either be, complex or negative or something like that. Okay. So let's write this. Let's say, is that, I'm trying to think now whether that is in fact the best way to approach, to continue here, or if it's, if I break things down into regions, Like, and not only that, then we still have to worry about, we're just, counting up the integers c where this all becomes true. So would it be a good idea to write down all the values of x which solve this in terms of c, and then just try and count and make sure that of all the values, exactly 6 of them are positive and distinct? I don't see off the top of like right off the bat a better way of doing this. Is there some kind of factoring thing that we could do here, right? We can factor absolute value of x out of this. Okay. I'm just going to start breaking it down into cases. This might be a pretty tedious way of doing it, but it really is the only thing I can think of. Okay, so I found a collection of C where, wait a minute. Sorry, this should be has 2 positive solutions. So if I assume all the absolute values give me positive things, then for all of these values of C, there will be 2 positive solutions. But I suppose I need to check. Do I need to check that these values of x attain positive values of these quantities? Man, this is going to be a pretty tedious and confusing problem. So the 2 positive solutions I have, one is greater than 20 and one is less than 20. That's a problem though, because if I want this thing to be positive, I need x to be between 0 and 20. Okay, so that's another thing to keep in mind, right? This is independent of C. We can determine when this thing is positive or negative. Maybe I should break it up then further. I'm going to kind of scrap that approach. Maybe I'll come back to it later. Okay, 20x minus x squared is equal to x times 20 minus x. If this is positive, it means x is between 0 and 20. So then we have 20x minus x squared minus c in absolute values is equal to 21. This will have a maximum value at 10. When x is equal to 10, this is equal to 100. So c, if I also restrict c between 0 and 100, like it might also help to, at this point what I'm thinking is to sort of approach the problem instead by trying to figure out what the graph of this looks like. It will depend on c, but and I only care about x being positive. When x is between 0 and 20, that's 20x minus x squared. And then I can of course continue it like this. Hold on, let's okay, and if I So that function there, that's 20x minus x squared in absolute values for positive x. Okay, now I want to take this and I want to subtract c. And c could, it doesn't say that c is positive. C could be a positive or negative integer. Okay. If x is negative, this gets shifted up. All right, let's, if I then subtract c, if x is negative, if c is negative, this gets shifted up, and the absolute value sign does nothing, and there would be maximum 3 positive solutions to this, which won't work. So I need this to get shifted downward, and then take the absolute value. So let me sort of redraw some stuff here. There's 20. There's 100. So this is the original function. And I'm going to shift it downward by c. That's equivalent to taking this axis and just moving it straight up. So that point is still 20. This value up here is now 100 minus c. This value is negative c. And now I want to take an absolute value of this. That will flip these 3 branches back up. So this will be at positive c. And these 2 values will be there like that. And if I draw a horizontal line at 21, you can see that there are going to be some values of c for which I get 6 solutions. So, oh wait, this value is also going to be at c, is it not? Yes. Okay, so I need c to be greater than 21. If c is equal to 21, then I have 1, 2, 3, 4, 5 solutions. This one only counts once. So I need c greater than 21. I also need 100 minus c to be greater than 21. So c is less than 79. Oops. So 79 greater than c greater than 21. And I think that'll do it, just based off of you know, the geometry, the sketch of the graph. I might kind of go through this again on my own in you know, quietly, to make sure that my my logic is correct. Okay, if I replace x with negative x, okay, well, let's first think about x equals 0. If I set x equal to 0, then c must be equal to plus or minus 21. But we need solutions to come in pairs, right? If I have one solution to this, replace x with a negative, and I get another solution. So I don't want 0 to be a solution, because then there would be an odd number of solutions. Okay. So I can think about only positive solutions, because then any solution to this, if I replace x with negative x, it'll also give a solution. Okay, so I'm only worried about positive solutions. And now let's consider the graph of this whole thing as it depends on c. I'm just going to go through these steps again, see if I catch any mistakes or something like that. I think it's a kind of a cool problem, though it's not clear, what the best approach is to take here. So that's 20. The peak of that part is at 100. What I'm plotting here is 20x minus x squared for positive values of x. It looks like that. So if I take an absolute value, this goes like that. Okay, now I wonder if c, thinking ahead a little bit here, I'm going to shift it down by c. And then anything that becomes negative is going to be flipped up to be positive. So this function, the function that I've graphed, of course, already, let me get rid of this, let me draw that part again as two separate things so I can... If I shift this up, then the absolute value doesn't change anything, and there will be at most 3 solutions. So I need c to be positive. So now, just copy everything. Now if I plot this, well, that here, that's the thing in absolute value. Now if I plot this in absolute value minus c, this peak is at 100 minus c. This axis just moves up like that. That point is negative c. Okay, that's good. And now, if I take yet another absolute value, we get this, and this point is a reflection of the one below, so that happens at c. And so does this. This one is also equal to c. And so I need if I draw a horizontal line at 21, it's clear I need C to be strictly greater than 21. I also need this number to be strictly greater than 21. And this turns into 79 greater than C. 79. Ugh. Okay, so C can be 22 up to 78. How many numbers is that? That's 78 minus 21 is equal to 57. That's the number of integers that C can be equal to, such that this original, the absolute original equation, has 12 distinct real solutions. That's going to be my answer. This is a cool problem. My first instinct was absolutely not to actually graph it, which is kind of surprising. Usually I take a more analytical approach to things, but it just seems, the original way of doing it, it might have worked out, but it's so tedious. And, once you solve for the values of x that work, given all the assumptions you make along the way, you then have to check that those values of x actually do in fact work. I'm not sure if, what did I derive here? I derived C greater than 21, which is one of the conditions we need that I had from below. But this one seems to be something. Did I do something wrong here? Should this be a C plus 21 or something like that? I don't know. Oh. Yeah. Oh my goodness. Oh, tons of my algebra was wrong here from the get-go. This should be a C plus 21. Right? Yeah. Oh well. Doesn't really matter because I did it this way anyway. This will be my final answer, 57. Hope it's correct. If it's not correct, I'll let you know. I'll let you know what the real answer is, but I can't guarantee that I'll be able to point out exactly where my mistake was. But I hope this is the right one in the end. Thanks for watching.